concepts in circles. But before starting, I have a question. Have you all revised my previous lectures on circles? If not, press the I button in the right corner and check out my all previous lectures. It will not only help you to learn the chapter wisely, but also will give you immense confidence in problem solving. So before embarking our new concepts in this tutorial, the Tangent Secant Theorem, the ideas of poles and polars, and the little bit of lattice points, I will give you a short summary of the tutorial taught in my 5th class. So grab your notebooks and let's get started. Boom. So let us start our today's tutorial, as I told you, by revising the subtopics of circle that we have completed in the previous class. We have learned what is a radical axis. It is basically the locus of a point moving in a plane in such a way that the power of the point with respect to two given circles will be equal, right? So from a point outside these two circles, if we draw two tangents, then the power of this point, let us say P, with respect to these two circles, they are equal. Then the locus of this point P is what called your radical axis. And how we get the equation of the radical axis? Simply by subtracting one equation of the circle from the other one. Then we have discussed about the properties of radical axis. The first property was that the length of tangents drawn from the radical axis on the circles are always equal. As the power of the point is equal, that is S1 equals to S2. So naturally, root over of S1 must be equals to root over of S2. And root S1 is the length of the tangent drawn from that point on the first circle. And root S2 is the length of the tangent drawn from that point to the second circle. Therefore, their lengths will be equal. The second property was the line joining the center of the circles is always perpendicular to the radical axis. That is, if you have two circles and if you join the two centers of these two circles, then this line will be always perpendicular to the radical axis. Is it clear? So this was our second property. The center joining the two circles is always perpendicular to its radical axis. That is, this angle is 90 degrees. Okay? The third property states that when two circles touch each other externally, then the transverse common tangent and the radical axis, they are the same line. This line is the transverse common tangent. For this case, this transverse common tangent is same as the radical axis. So if we know that two circles are touching each other externally and the question is to find out the equation of transverse common tangent, we will simply find out the equation of its radical axis, which will be the same line. And finding out radical axis is simpler than finding out the transverse common tangent. For radical axis, we will simply subtract the equation of one circle from the other to get its equation, right? So when two circles touch each other externally, then transverse common tangent and the radical axis, they are one and the same line. Fourth property states that when two circles touch each other internally, that is, say this is one circle and this is another circle, they are touching each other internally, then their direct common tangent and the radical axis, they are the same lines. Am I correct? They are the same lines. So in this question also, in the question if they have given to find out the direct common tangent, and if we know that the two circles touch each other internally, then finding out DCT, that is direct common tangent, is same as finding out the radical axis because they are the same line. As I told you, finding out direct common tangent and transverse common tangent is little bit longer than finding out the equation of the radical axis. So it is easy to find out the radical axis the moment you know that they are touching each other internally. Because the equation of direct common tangent and the radical axis, they will be the same one. Now, when two circles intersect each other, suppose this is one circle and this is another circle, these two circles are intersecting each other at 2 points. Then the radical axis and its common chord, they are one and the same line. This line is the equation. This line is basically the radical axis as well as it is the common chord for both the circles. Okay? This happens when two circles intersect each other at two distinct points. The sixth property states that for any concentric circles, the radical axis is not defined. For any concentric circles, you cannot find out its radical axis because it is not defined there. That's pretty simple. Because if there are two circles like this, suppose they are intersecting, suppose these two circles are concentric. Now here you cannot find out the radical axis because as we know from the property, from the radical axis, if you draw tangents to both the circles, they are going to have equal length. So from here, you cannot draw tangents to two circles which are having lengths equal. Isn't it so? This tangent and let us say if this tangent, the length of these two tangents will never be equal. Because since these two circles are concentric, so their equation will be something like this. Let us say for the first circle it is lambda 1 and for the second circle which is concentric to the first circle is lambda 2. So what will be the length of the tangents for the first circle? From the point, let us say x1 comma y1, it will be root over of and the length of the tangent for the second circle will be these two lengths will never be equal. That is clearly understood. Why? Because this part is same for both the cases. The magnitude for these two will be same. But as lambda 1 and lambda 2, they differs. So the length of the tangents will definitely differ. So they will be never equal. That is why for concentric circles, radical axis is not defined. Clear?
And the last property on radical axis is radical axis always bisects the direct and transverse common tangent. If you have the radical axis for two circles, let us say these are the two circles. Let it be anywhere. I am taking two disjoint circles. Now, if I draw a tangent, a direct common tangent here, and the transverse common tangent here, though there will be two direct common tangents and two transverse common tangents, but I am taking one. The radical axis is always going to bisect those tangents. That's a common thing. Why? Because we know from the definition that any point on the radical axis, if you choose, the length of the tangents drawn to two circles, they will be equal. So as this is the dotted line is the radical axis, so if you choose any point on the radical axis, the length of the tangent to two circles, they will be same. That implies the radical axis is bisecting the direct common tangent. At the same time, if you choose this point on the radical axis, again the length of the tangents drawn to two circles, they will be equal. Thus, this point, the selected point, is basically the midpoint of the transverse common tangent, right? So the property says any radical axis for two circles, it will always bisect its direct common tangent as well as transverse common tangent. Is it clear to everyone? Okay, so now let us move for radical center. What do you mean by radical center? If we take three circles and pairwise if we find its radical axis, they are going to meet at only one point. Okay, that is all those three radical axes are concurrent, and the point in which all the radical axes are meeting is what called your radical center. How to find out the radical center in problems? Solving two radical axes will give us the point of intersection, which is nothing but the radical center of the system of three given circles, right? Now let us discuss about the properties of radical center. The first property that we have learned is that the length of the tangents drawn from the radical center upon three circles is always same. That is, from this point O, if you draw three tangents on these three circles, their lengths are going to be the same. Is it clear? If you draw three tangents from this point on these three given circles, then their lengths will be equal. That is, this length of the tangent is equals to this length as well as is equals to this length. Is it clear? So from the radical center, if you draw tangents, their lengths are going to be the same one, of equal length. The second property states that if you choose a triangle, let us say ABC, and if the three circles are described on the three sides of the triangle, taking the sides as diameter, then we are going to have three circles described on these three sides. Now, for these three circles, we are going to have a radical center. The property states that the radical center and the orthocenter for the triangle ABC, they will be as one and the same point. Is it clear? What is orthocenter? If you draw perpendiculars from vertices, from each vertices on their opposite sides, they are going to meet at a point which is called your orthocenter. Am I correct? And this orthocenter is same as the radical center formed by these three circles, described on the three sides as their diameters. Is it clear? Okay, so the third property on radical center states the locus of the center of a variable circle which cuts two given circles orthogonally is same as the radical axis between the two circles. It is stating that if there are two circles, suppose this is one circle and this is another circle, now you have to find out the locus of that circle, I mean the locus of the center of that circle, which is intersecting these two given circles orthogonally. Then the locus of this center will be nothing but the radical axis for these two circles. Is it clear? And last but not the least, this property states that if there are three circles, and if there is a circle which is intersecting these three given circles orthogonally, then the center of this circle will be same as the radical center for these three circles. Okay? And the radius of this circle will be the length of the tangent drawn from this center, which is same as the radical center for these three circles, will be the tangent length drawn on any circle. So it is the radius for this circle will be the tangent length drawn from the radical center on any of these three circles, because the length of the tangents drawn from the radical center on three circles, they are equal. So that will be the radius for this black circle. Is it clear? So these are the four properties on radical center we have to remember. And the last thing that we have done in my previous class was coaxial circles. What is coaxial circles? If a system of circles are having the same radical axis, that is, for a system of circles, if the radical axis is common, then we say that all those circles are coaxial circles. Is it clear to all? Absolutely. So now we will start with today's journey, which we are going to complete here. And the first thing is that in our new lecture in this class is Tangent Secant Theorem. This theorem states that if there is a circle and let us say there is a tangent and a secant drawn from a same point. Let the tangent be PT and the secant which is touching the circle at A and B. Then the theorem states that PT square equals to PA into PB. And this theorem you have all proved in class 10 by using geometry. So what I will do here, I will prove the same theorem by the means of coordinate geometry, right? Let us say the point PB x1, y1 and the equation of the circle be x square plus y square equals to a square. You can take the general equation of the circle also, no problem, you are going to get the same thing. Understand the conception first. So now, what is your PT square? This is basically nothing but the power of the point P with respect to the circle x square plus y square equals to a square. Am I correct or not? Pt square. Pt is basically the length of the tangent, and the square of the length of tangent is nothing but the power of that point. Now, what will be Pt square? That is the power of the point. It is nothing but your x1 square plus y1 square minus a square, right? Okay, now let us say that slope of the secant be tan theta. So by using the parametric equation of a line, we can say that any point on this secant will be represented by x1 plus r cos theta, comma, y1 plus r sin theta. Am I correct? This is any point on this straight line or the secant PAB, because this is the parametric equation of a straight line.
Now let us assume that this point be either A or B. So the point is lying very much on the circle. Hence, it must satisfy the equation of the circle. Yes or no? Let the distance PA be R1.
And the distance PB be R2. Okay? So if I put in the equation of the circle this point, what we are getting? Now if I open the brackets, right? So let me just form this quadratic equation in R. We are getting, from this 2 we are getting only R square. From this 2, if I take R common, we are having, and we are left with, which is equals to 0. So this is a quadratic equation in R. So naturally we are getting two values of R because the line is intersecting the circle at 2 points. So the roots of this equation will be R1 and R2. Now what is the product of these two roots? It will be, yes or no? The product of two roots is c by a, so this gives us this divided by 1. So R1 into R2, which is basically your PA into PB, that gives us x1 square plus y1 square minus a square. Now we can easily see that is nothing but your PT square. Am I correct or not? So we have proved the same theorem by using coordinate geometry. Okay? Is it clear to everyone? So whenever we draw a tangent from a point to a circle and the secant through that point, then the relation between the tangent and the secant is given by this formula, PT square equals to PA into PB. Now I can see a very other interesting thing here, that if I draw another secant from P such that it is intersecting the circle, let us say at C and D. In this case also, this relation will hold true. That is, your PT square will be same as your PC into PD. Tell me yes or no? Now, if you compare these two equations, what we can see? We can see that both are equals to PT square. So I can write PA into PB. This will be equals to PC into PD. This is also true for every case. That is, from a point which is outside the circle, if we draw two secants, then the relation between those secants will be PC into PD equals to PA into PB. This is always true. Can we remember this? Easy thing? Okay, what else? Before moving further, let me just summarize what we have got. We got that whenever we draw a secant like P, A and B, where A and B are the 2 points where the secant is intersecting the circle, then we have seen that PA into PB, this product is always equals to the power of the point P with respect to the circle. Is it clear? Which is equals to PT square, because PT square is nothing but the power of that point with respect to the circle. So the product PA into PB is always equals to the power of the point with respect to the circle. Now, let us assume that this point P be inside the circle. My question is, then also this relation holds true. That's the question. So what I'm doing, let us say a point P inside the circle. Let us say this point be P, and this is my AB, and this is another chord CD. Now, is this relation is true for this one also? My answer is yes. Now you will say, sir, I have understood the first case when the point was outside. We have drawn a tangent. But when the point is inside the circle, we cannot draw a tangent. And until and unless we can draw a tangent, we cannot say that PT square equals to PA into PB. Yes, if you think in that manner, then we will say that this relation is not true. But actually the thing is not happening in that way. When the point P is inside the circle, we know what is power of the point P in that case. When the point P is inside the circle, the power of the point P, which is your S1, which is same as your PT square, this is less than 0. When the point is inside the circle, the power of the point is less than 0. Think in that way. But still the power of the point exists. You are getting a negative value, but it exists. And which will be same as your PA into PB. If you consider the chord APB, but if you consider the chord CPD, in that case also it will be PC into PD, which are both equals to your S1. Now you can ask me, sir, but here your S1 is less than 0. How these two distances can be less than 0? That is the reason why I have proved the formula by using this form. In this form, what does your R1 and R2 represents? It represents the length PA and PB. Yes or no? In this case, it represents the length PA and PB. But you see, the point A and point B, they are on the opposite side of point P. That is, if R1 is considered to be positive, then your R2 will be considered as negative. So in that case also your PA into PB, when we are considering the fact in parametric form, we can see that yes, it is possible that this product is coming to negative, because these 2 points A and B, these are on two opposite ends of P. Am I correct? So even if the point P is inside the circle, this relation holds true. That is, PA into PB will be equals to PC into PD. Is this clear? So we will simply remember in this way that whenever the point is outside the circle, your pt square, which is actually the power of the point P, which is equals to your PA into PB. And if you draw 2, 3, 4 or more than one secant there, then the condition PA into PB equals to PC into PD, that holds true. This is the first thing you have to remember when the point P is outside the circle. And also remember that the same relation holds true even if the point P is inside the circle. Is it clear to everyone? Absolutely? Okay, so let's move for some problems based on this. In this question, they have said that two circles intersect at the points 1, 1 and 3, -1, and y-axis is the common tangent as shown in this figure. So we have to find out the length of AB. See, one way of doing this sum, though it will be a long method, but still you are going to get your answer. The method is that when we know that a family of circles passing through two given points, so we can find out that family by writing S1 plus lambda L equals to 0. What is S1? S1 is basically the equation of the circle whose extremities of the diameter are 1, 1 and 3, -1. So we know the equation of the circle S1. I'm not doing it because I'm not going to do this sum in this method. I'm simply giving you the hints. So now we know S1 equals to 0. What is S1? Again, I'm telling you, it is the equation of the circle in which the extremities of the diameter are 1, 1 and 3, -1. And L is the equation of that line passing through these two given points. You can simply use two-point form to get the equation of this line L equals to 0. Now, any circle which is passing through the point of intersection of this circle and this line is given by S1 plus lambda L equals to 0. Now, in our problem, the circle is touching the y-axis. That is, your y-axis is the common tangent. So now what we will do to get the value of lambda in this family of circles, we will put f square minus c equals to 0, because we all know that when a general equation like this one is touching the y-axis, then 2 times root over f square minus c equals to 0. That implies f square minus c equals to 0. So simply by using this equation, we can easily get the value of lambda. The moment we get the value of lambda, we know the equation of the circle. Here we will get two values of lambda because it's a quadratic equation. So we will get two values of lambda. So we will get the equation of these two circles. Then we have to find out in that equation of the circle, you have to find out where it is touching the y-axis. So in that equation, you will put x equals to 0. So if you put x equals to 0, you are going to get the point where the circles are touching the y-axis. That is, in that case, you will know the coordinate of A and coordinate of B. From there, you can find out the distance AB. So it's a long method. I have given you the hints. Even if you try the problem by using this method, you can do the sum. There is no harm. But the thing is that it will be a long one. It will consume a lot of time solving this sum. So now we will try to apply some other method to solve this problem. What I will do is, I will simply draw its common chord. This is the common chord, right? Let me say this common chord is intersecting the two circles at C and D. The coordinate of C they have given is 1, 1, and the coordinate of D is given 3, -1. So now we can find out the equation of this common chord by using two-point form. What will be the equation of CD? It will be so that gives us y minus 1 equals to minus x plus 1. That gives us x plus y equals to 2. Am I correct? This is the equation of CD. Now, if I put x equals to 0, we can easily see that this line is intersecting the y-axis at 0, 2. Therefore, if this point is P, we can write the coordinate of P as 0, 2. Is it clear? Now we can find out what is our PC. The distance will be 1 square plus 1 square, that is √2, and the distance PD will be root over 3 square plus 3 square, that gives us 3√2. Am I correct? Now we can easily see that by using tangent secant formula, we can write PA square is nothing but PC into PD. Am I correct? Because your PCD is the secant to the first circle and PA is the tangent to this first circle. So PC is √2 into 3√2, so that gives us 6. Therefore, PA is nothing but root over of 6. Now, as we all know that your PCD is the common chord. At the same time, if we observe, we will find, since these two circles are intersecting each other at two distinct points, this common chord is also the radical axis for these two circles. Am I right? And we all know that any point on the radical axis, if you draw two tangents to the given two circles, their lengths are equal. In this case, PA is equals to your PB, because P is a point on the radical axis. Thus, the length AB will be nothing but 2 times PA. So that gives us 2 times √6 is the length of AB. Is it clear to all? Have you understood this question clearly? So what we have done basically, we have simply joined the common chord, and simply by applying the tangent secant formula, we can easily get the length of AB in this problem. Is it clear? Okay, let us move for the next problem. See this question. ABC is a right angled triangle. Let me draw a right angled triangle first. ABC is a right angled triangle like this. Right angled at A. So this is my A, this is B, and this is C. Then what happened? The circle with center A, and radius AB, okay, cuts BC and AC internally at D and E. Okay, let me just draw the circle first. So how you have drawn this circle? By taking A as the center of this circle and AB as the radius, we have drawn this circle which is intersecting the side BC at D and AC at E. Is it clear? And they have given that BD is 20. That is, BD, this length is 20 and DC is 16. So this length is 16. Okay. So you have to find out the length of AC. How to do this sum? You have to find out the length of AC. Let me say that this radius be R. The radius of this circle be R. So this length is also R. That is AE is also R. Okay. Then how to find it out? Let me do one thing. Let me just draw a tangent from point C on this circle. Let us say the point of contact be T. So here we can write that your CT square is equal, by using the tangent secant formula we can write CT square equals to CD into CB. So that gives us 16 into CB will be 20 plus 16. So that gives us 16 into 36, right? So your CT is coming to 4 into 6, that is 24. Am I correct? So the length of the tangent drawn from point C to the circle is 24. Okay, so we have to find out what is AC. So for that, what I'm doing, I'm simply joining this point of contact with the center of this circle. So this length will be again equals to R, and this is 90 degree. So taking the triangle ATC, look it carefully, taking the triangle ATC, we can write that CT square plus AT square is equals to AC square. So your AC square comes to, CT square is how much? It's 24 square plus AT square is the radius R square. Okay? Okay. Again, we have been given that angle CAB in the triangle CAB. Angle CAB is 90 degrees. So again, I am applying Pythagoras theorem. So we can write that AC square plus AB square will be equals to BC square. AC square plus AB square is how much? It is your R square, which is equals to BC square, which is nothing but 36 square. Am I correct? So from this equation, we are getting AC square minus R square is 24 square. And from this equation, we are getting, this is my equation 1 and this is equation 2. AC square plus R is 36 square. We need to find out AC. So let me just add this 2. So we are getting 2 times AC square equals to 24 square plus 36 square. Am I correct or not? So this can also be written as, because from this equation we will naturally get the value of AC, which is our required length. So AC square can be written as, let me directly not multiply this. Let me see whether it can be simplified a little bit or not. So it can be written as actually 12 into 24 plus 18 into 36. So that gives us how much? This is 6 into 2 into 24 can be written as 6 into 4. This is 6 into 3 into 6 into 6. So now your AC will be actually root over of this whole thing. 6 into 2 into 4 into 6 plus 6 into 3 into 6 into 6. So now for this 2 6, 1 6 will come out, root over 8 plus 18, right? So it is coming to 6 root 26, correct? Therefore, the length AC is nothing but 6 root 26. Let me review the answer. Yes. Have you understood? Are you understanding how I am applying the second tangent secant theorem? Okay. Okay, let me take another problem. So this is a big question, but we will read the question slowly and we will understand what actually they have given. They are saying that through a given point P5, 2, so there is a point. Through this point, seconds are drawn to cut the circle. So there is a circle also. So through this point, seconds are drawn to cut the circle at A1, B1, A2, B2, and so on till A5, B5. It means that 5 seconds are drawn. So let me just draw 5 seconds from this point P. This is the first one, the second one, the third one, this is the fourth one, and this is the fifth one, right? So these are the 5 seconds which has been drawn from point P. And they're intersecting the circles respectively at A1, B1, A2, B2, A3, B3, A4, B4, and A5, B5. Am I correct? So these are the 5 seconds. And they have given the information PA1 plus PB1 is 5, PA2 plus PB2 is 6, and so on. PA3 plus PB3 is 7, then 8, then 9. And we have to find out the value of this sigma, the expression that is given. What is the expression given? Sigma pi square plus sigma pbi square, where I starts from 1 till 5, 1 till 5, right? We have to find out the value of this expression. And what is the note? ARBR denotes the line passing through this, meets the circle this at the point ARBR. Okay. That is, they are saying that the first second is intersecting the circle at 2 points, A1 and B1, and so on for the other seconds. So now, how to find out this value? Only this much is given to us. Okay. Now, let us see this. If I expand this sigma, we are going to have PA2 square plus PB2 square. Similarly for the other one also, I'm not writing. So if I open the first thing, we will understand the pattern and we will repeat for the other terms which are given here. So if I apply A square plus B square form, we are going to have tell me yes or no. Same thing for the other terms also. So actually we are getting PA1 plus PB1 whole square. Similarly, PA2 PB2 whole square. And this thing goes on, and the last term will be PA5 PB5 whole square, right? And the second terms will come in this. If I take 2 common, we are having PA1 into PB1, PA2 into PB2, and also the other terms. The last term will be PA5 PB5. Okay? Now, the values of these terms we know. We have been given that PA1 plus PB1, PA2 plus PB2, all those values are provided to us. So, the first thing will become 5 square plus 6 square plus 7 square plus 8 square plus 9 square, right? And the second term we have to find out. What is that? Now, observe carefully. If I draw a tangent from the point P on this circle, let us say this is my PT. So, can we say that your PT square is same as your PA1 into PB1, same as your PA2, PB2, same as your PA3, PB3. The tangent secant formula I'm using, similarly PA4, PB4 and PA5, PB5, correct? Let us say this is K, right? So now, what is your PT square? What is actually PT square? This is basically the square of the length of the tangent, which is same as power of the point P with respect to the circle x square plus y square equals to 25. Am I correct? And what will be this value? This value will be, what will be the power of the point P with respect to this circle? It will be 5 square plus 2 square minus 25. So that gives us 4. Is it clear? Therefore, the value of K is nothing but 4. So, our expression, the value which we have to find out, let me just write this thing as my S. I will do it afterwards. This calculation I will do afterwards. So, let me denote this thing by S. Minus 2 times, there are 5 such terms which are all equals to K in the second bracket. So, it will be basically 5 times K. So that gives us the value of the expression becomes for S minus 10K. That is S minus 10 into 4. That gives us S minus 40, right? So now if we can find out the value of S, we can easily find out the value of the given expression. So what is our S? S is 5 square plus 6 square plus 7 square plus 8 square plus 9 square, right? Which can also be written as 1 square plus 2 square plus 3 square goes on till 9 square, and we are subtracting 1 square plus 2 square plus 3 square plus 4 square. So for this we are applying the formula n into n plus 1 into 2n plus 1 by 6. So we are having n into n plus 1 into 2n plus 1 divided by 6 minus same thing here, n into n plus 1 into 2n plus 1 divided by 6. So the value is coming to so this is 15 into 19 minus, so this is 10 into 3. So we are having 19 into 15 gives us 285 minus 30. So that gives us 255. Am I correct? So the value of S is nothing but 255 minus 40. So that gives us 215. Therefore, the value of the given expression is nothing but 215. Have you understood this? Have you understood this? So what I've done, I've simply applied the properties of tangent secant theorem, nothing else. Okay, let's move for the next problem. Wow, it's a great question. They have said there are 5 circles touching each other consecutively and the lines L1 and L2, these are the two common tangents to the given circles. The radius of the first circle they have given as 3, and the radius of the last circle they have given 243. Then you have to find out the radius of the middle circle. That is, we have to find out the radius of this circle. Let me give a name, R3. So R3 is the radius of the middle circle. We have to find out what is that radius, right? So let me do one thing. Let me first take 3 given circles. First circle is this. The second circle is this. And the third circle is this, let us say. And we are having a common tangent. And let me draw the second tangent. Okay. Now let us say the radius of the first circle be, we know it is given 3, but let me denote this thing as R1. The radius of the second circle, let us say this is R2. And the radius of the third circle, let us say this is my R3. Okay. Now, let me join their centers. Okay. This all angles are 90 degree. Now, let me give a name first. Let us say this is my point A, this is B, this is C, D, E, F. Now, from point A, let me draw a perpendicular on the radius of the second circle. And same thing I am doing, drawing a perpendicular from point B on the radius of the third circle. Is it clear? Now, observe carefully. This is 90 degree. So, this length, this is R1. So, this is also R1. Can you remember we have done this thing when we have found the length of the direct common tangent and transverse common tangent? This exactly the same method I have used there. That is why I told you that derivation is important. You must know how it is derived, all the things. You see, that derivation method I am applying in this problem. So you must know it. So this length will be what? It will be your R2 minus R1. Similarly, if B is R2, then this length is also R2. So this length will be R3 minus R2. Am I correct or not? Again, let us give a name of this point. Let us say this point be G, and this is, let us say, H. Now let us consider the triangle AGB and triangle BHC. Let us consider these two triangles. Now in this triangle we can see that this angle and this angle, they are 90 degree. DEGA is basically a rectangle. Therefore AG is parallel to DE, right? Similarly, rectangle E, quadrilateral EFHB is also a rectangle. Therefore, I can say that BH is parallel to EF, right? As BH and AG are parallel to the same line, L1. This is my L1 actually. Since they are parallel to the same line L1, so I can say that BH and AG, they are also parallel. Am I correct? And here your AC is the transversal. If AC is the transversal, we can say that this angle will be equals to this angle, right? So obviously the other angle will be definitely equals to the other angle left. Therefore, your triangle AGB and BHC, they are similar. They are similar triangles. If they are similar triangles, we know that their sides are in proportion. Their sides are in proportion. So can we write AB over BC is R2 minus R1 divided by R3 minus R2? Am I correct? What is AB? AB is basically R1 plus R2. And what is your BC? It is R2 plus R3, which is equals to R2 minus R1 by R3 minus R2. Is it clear? Now, if I take, let me do it here. So if I take R2 plus R1 divided by, I can write in this way. So now by applying componendo and dividendo, we get 2 times R2 by 2 times R1 equals to 2 times R3 by 2 times R2. Am I correct? So now 2 goes off. That implies R2 square is equals to R1 R3. Very, very important thing that we got. What does it mean? It means that your R1, R2, R3, these 3 radii are in geometric progression. So naturally, if we take the other 3 circles, we are going to prove the same thing because they are symmetric. The same thing is happening, whatever has happened with these 3 circles. So we will say that the radius of all those circles given in the figure are in GP, are in GP. So what you will write? You will write that R2 over R1 is same as R3 over R2 is same as R4 over R3, which is same as R5 over R4 because they are having a common ratio. Let us say the common ratio be R. The last radius of the circle, this last circle, the radius of whose is given to 243, that is R5 is 243. So we can write this thing as R1 into R to the power 5 minus 1 is 243 because the last term is calculated in GP in which way? A R to the power n minus 1. A is the first term. Here the first term is the radius of the first circle, which is R1. And the common ratio is R here. And number of terms, that is number of circles present, is 5. So R1 into R to the power 5 minus 1. Your R1 is given to 3. And R I don't know. It is 243 implies your R4 is 81 implies R is basically 3. Am I correct or not? Therefore, the common ratio in this problem is 3. So what will be your R3? It is nothing but R1 into R3 minus 1. That gives us R1 into R square. So that gives us 3 into 3 square, which is nothing but your 27. Therefore, the radius of the middle circle is nothing but 27. Have you got this one? Have you understood this? What I have done, I have taken the first 3 circles and tried to find out the relation between the radius. And we saw that the radius are in GP. So simply by using the GP formula, we get what is the radius of R3? That is the middle circle, right? It's a fantastic sum. Okay, so now let's move for another conception. It states that if the lines with slopes m1, m2, there are two lines whose slopes are m1, m2, intersect coordinate axis at 4 concyclic points. Okay. Then your m1 into m2 is equals to 1, not minus 1, 1. What they're saying? They're saying that, let me just draw the circle first, and then let us draw the coordinate axis. Now what they have said that there are two lines. One is having slope m1. Let us say this is the line. This line is having the slope m1 and other line is having the slope m2. This is the other line. So it is, these two lines are intersecting at 4 concyclic points. Concyclic points means through these 4 points you can draw a circle. I have drawn this circle. So let us say AB with the point of intersection on the coordinate axis by the first line whose slope is m1. Let us say the equation be y equals to m1x plus c1. Okay? And the second line whose slope is m2 is intersecting the coordinate axis at 2 points. Let us say it is C and D. And equation, let us say this is m2x plus c2. Now, the thing is A, B, C, D, these 4 points are concyclic. Then the relation between their slopes means the slope of these two lines is given by m1 into m2 equals to 1. This I will prove. Don't worry about it. But first you understand what actually they are saying. There are two lines intersecting the coordinate axis at 4 points. These 4 points are concyclic. Then the product of their slopes will be equals to 1. Right? Now, can you please tell me, now I am proving this. What will be the coordinate of B? The coordinate of B will be, in the first equation, if I put y equals to 0, we are getting x as minus c1 by m1. So your coordinate of B is, I am writing it here, the coordinate of B is minus c1 by m1 comma 0. Is it clear? And the coordinate of A will be, put x equals to 0 in this equation to get y equals to c1. So coordinate of A is 0 comma c1, right? Similarly, the coordinate of D will be, put y equals to 0 in the second equation, we are getting, this is the coordinate of D, and the coordinate of C will be, is it right? Now we can easily see from this is the origin, let us say O. Now we can see that this from this point O, these are the two seconds drawn. One is OBD, another one is OCA, right? Now we know from the Tangent Secant Theorem that your OB into OD will be equals to OC into OA. Am I right? What is your OB? Your OB is minus C1 by M1 into, what is OD? That is minus C2 over M2, which is equals to OC. What is your OC? OC is C2. And what is your OA? OA is C1, right? So from here we are easily getting that this C1, C2 will get cancel off, minus minus will become positive. So we are getting M1 into M2 is nothing but 1. Hence, we have reached the conclusion that when two lines intersect the coordinate axis at 4 points, which are concyclic, then the product of their slopes will be equals to 1. Is it clear to everyone? Absolutely. Okay, let me take a problem based on this. The question is, the lines 2x plus 3y equals to 6 and ax plus by equals to ab. These two lines meet the coordinate axis in 4 distinct concyclic points. Concyclic points. Where are these points? On the coordinate axis. Then show that whatever is given. We know that when the two lines intersect the coordinate axis at 4 points which are concyclic, then M1 into M2 is 1. M1 is the slope of the first line, M2 is the slope of the second line. So what is the slope of this line? Your M1 is minus 2 over 3. And what is the slope of the second line M2? That is minus A over B. Am I right? Since the 4 points are concyclic, hence M1 into M2 is 1. That is minus 2/3 into minus A over B is 1. So that gives us 2A equals to 3B. That's it. So if you know the information, if you have the information, until and unless you have the information, you cannot solve this kind of problems. So the moment you have the information that when two straight lines intersect the coordinate axis at 4 distinct points which are concyclic, then the product of the slope of those two straight lines will be equals to 1. You can solve this kind of problems in fraction of seconds. Okay? Okay. So I hope you have understood all the theorems and the note, whatever we have discussed so far, in context to Tangent Secant Theorem. So now let us move for the next part of our lecture, which is pole and polar. Pole and polar is a subtopic in the circle chapter which has been excluded from JEE Advanced syllabus. But as pole and polar are all concerned about the chord, tangent and the locus, so it can come any time in the examination, even when they have said that pole polar is not included in the syllabus, because locus is very much included in the syllabus. So this question can come as a locus. So you must do this part of the conic section definitely. Okay. So what does this pole and polar means in circle? Let us try to understand the thing by a figure. Suppose a circle is given to us and we are having a point. In this case, I am considering the point is outside the circle. From point P, let me draw a straight line which is intersecting the curve. I mean, in this case, it's a circle at 2 points, say Q and R. Now at Q and R, if we draw tangents, at the point Q and R, if we draw tangents, they are going to meet at a point, let us say S. The question is, we have to find out the locus of the point S. We have to find out the locus of the point S. That's the question. Forget about pole and polar. Only think in this way, that a point P is given to you which is outside the circle. I'm taking this case as a point which is outside the circle, and the coordinate is x1, y1. From point P you have drawn a line which is intersecting the circle at 2 points, at Q and R. Now at Q and R we have drawn 2 tangents. They are meeting at a point S. We have to find out the locus of point S. That's it. So how to find out the equation of locus S? Okay, so see this one. And the equation of chord of contact is T equals to 0. That is, the equation of the chord of contact, let me take the equation of the circle B, x square plus y square equals to a square. I am taking the standard one. You can do it by general equation also. You are going to get the same thing. I am trying to make you understand about the theory. That is why I have taken a simple form, that is the standard form of the circle. Therefore, what will be the equation of the chord of contact QR? It will be hx plus ky equals to a square. Am I correct? So this is the equation of QR, which is actually the equation of PQR. Right? Now, the line PQR is passing through the point x1, y1. Hence, it must satisfy this equation. Therefore, we are getting hx1 plus ky1 is equals to a square. This is an equation which contains your h, k and the given constants. Hence, this is the equation of the locus. Therefore, the equation of the locus S is xx1 plus yy1 equals to a square. Am I correct or not? This is the equation of the point S, right? Now let us try to understand. Let me give a name of this given point P and the locus of point S. The point P is what called your pole. This point P is what called your pole. And the locus of point S, that is the equation of the locus is this. This locus is what called your polar. Am I correct or not? So this is the polar, this is the equation of the polar, which is basically the locus of point S. And P is called the pole of this circle. Is it clear? So remember in this way, your pole is always a point and polar is always a straight line. Remember in this way, it will be better for you to remember. Pole is a point and polar is a straight line, and this polar is basically the locus of point S, which actually obtained by the point of intersection of the tangents drawn at 2 points where the line from the pole intersects the circle. Okay, remember in this way. Now, if you observe, we will find that with respect to the point P, if I consider this equation, that is the equation of the polar, actually becomes the equation of the chord of contact. Isn't it so? That is, the chord of contact equation is T equals to 0. So when the pole is outside the circle, the polar is a particular line which is nothing but the chord of contact. Is it clear? Absolutely. And its equation will be t equals to 0. Now I will show you that even if this point is inside the circle or on the circle, everywhere the polar of the pole P will be t equals to 0. Let me show it. Let me take a circle here, and we are taking a pole which is inside this circle. Let me say this is my point P. Now from point P I am drawing a line which is intersecting the circle at 2 points. Let us say at Q and R. Now at Q and R, if you draw two tangents, they are going to meet at, let us say they meet at S. Now if we want to find out the locus of point S, check it. With respect to point S, because P is the pole which is inside the circle, and the locus of point S will be the polar for this circle with respect to the pole P. So in this case, what will be the equation of QR? With respect to the point S, your QR is the chord of contact. Therefore, equation of QR is XH plus YK equals to S square. The equation of the circle remains the standard one. X square plus Y square equals to S square. Now, as the chord of contact is passing to the point x1, y1, hence it must satisfy this. Therefore, hx1 plus ky1 equals to S square. So this is the equation of the locus which gives us xx1 plus yy1 equals to S square. Tell me yes or no. So you can easily see that the equation of the polar, here also it becomes t equals to 0. But this line, don't say it incorrectly that this is the equation of the chord of contact. No, because the point x1, y1 is on the chord of contact. The equation of chord of contact is when the point is outside the circle. From there, if you draw two tangents, then the equation of the chord becomes the same thing. But in that case, your x1, y1 lies outside the circle, right? In this case, don't say that this is the chord equation of a chord of contact. No, this is the equation of a line. This line has no particular name, but it's a line. But see, in this case also the equation of the polar is still t equals to 0. Are you getting my point? So what I have shown you, that whether the point is outside the circle or inside the circle, I mean the pole is outside the circle or inside the circle, the equation of the polar is always t equals to 0. But when the pole is outside the circle, the polar is the chord of contact. When the pole is inside the circle, it is a straight line. The polar is a straight line. It has no particular name. It's a straight line, simple, whose equation is t equals to 0, right? Now the last thing which is left with us, if the point is on the circle, if the point is on the circle, then what will happen about its polar? This point is P. P is the pole which is lying on the circle. X square plus y square is a square. The coordinate of point P is x1, y1. Now, what I will do, I will simply draw a chord. Now, at these 2 points, let us say this is P and Q. at these 2 points P and Q, if you draw tangents, it is going to meet somewhere here. Yes or no? Let us say the chord is this. Let us say our chord is this. Say this one. Okay? So even if at these two extremes, if you draw the tangents, this is the tangent at P, and let us say this point be R, and if at R I draw a tangent, it is again going to meet at the point, let us say S. Now we can easily see that your S and S dash is basically, because in this case also the equation of the polar will be T equals to 0. Yes or no? That is xx1 plus yy1 equals to S square. The equation of the polar in this case also, it will be xx1 plus yy1 equals to S square. Are you getting the point? If the point P, that is the pole of this circle, is on the circle, then if we consider any line PQ, which is actually the chord of this circle, at these two extremities P and Q, if you draw tangents, they are meeting at S dash. Now let us say this point be H comma K. Now I want to find out the locus of S dash. So what you will do? You will say that the equation PQ, because PQ is now the chord of contact with respect to S dash to this given circle. The equation of S dash is xh plus yk equals to S square. As it is passing through the point x1, y1, hence it must satisfy this. Therefore, the equation of the locus S dash, that is the locus of the polar, is basically xx1 plus yy1 equals to S square, right? So this is the equation of the polar. Again, this is nothing but T equals to 0. But in this case, this T equals to 0, that is the equation of the polar, represents a particular line. And we can see that line is nothing but the tangent at the point P, that is the equation of the tangent at the pole. Okay, so what we have learned, let me just summarize this. We have learned that if the pole, whether it is outside the circle or inside the circle or on the circle, it doesn't matter. The equation of the polar is always T equals to 0. And if the point is lying, the pole is lying outside the circle, the polar will be the chord of contact. If the pole is inside the circle, then the polar T equals to 0. This particular line has no name. It is just a straight line. Okay, but equation is T equals to 0. And if the point, that is the pole, is on the circle, then the polar is the tangent to that circle at the pole. Are you getting my point? So these three things you have to remember for pole and polar. Okay, so have you seen in pole and polar there is something new that we have learned? No, it is simply two specific things that we are dealing with. One is pole and another one is polar. Pole is a point and polar is always a line. Okay, and the equation of polar is always T equals to 0, irrespective of the position of the pole with respect to the circle. That's it. That's exactly what we have learned. Okay. So I have simply summarized this thing here. If point P lies outside a circle, the polar and the chord of contact of this point P are the same straight line. If the point P lies on the circle, the polar and the tangent to the circle at P are the same straight line. But if the pole is inside the circle, we will get the polar, the equation of the polar in all these three cases will be t equals to 0. But this line has no particular name. It is not a particular line. It is simply a line. When the pole is lying inside the circle. That's it. Clear? Okay, let us just move for some problems based on pole and polars. See this question. Find the equation of the polar of the point 1, 2 with respect to the circle this. Now here you don't need to check whether this point is on the circle or outside the circle or inside the circle, because I don't know where this point is. Because to find out where this point is, you have to check the power of the point. But no need to check it. Because wherever the point may be, the equation of the polar is always t equals to 0. Therefore, the equation of the polar in this case will be xx1 plus yy1 minus x plus x1 plus 2 times y plus y1 minus 4 is 0. So in place of x1, y1, I am writing 1 and 2. So we are getting therefore the equation of the polar will be 2y minus x minus 1 plus 2y plus 4 minus 4 is 0. So 4 goes off, xx goes off. So it is basically 4y minus 1 equals to 0. Correct? Therefore, the equation of the polar with respect to the pole 1, 2 is given by 4y minus 1. It's a straightforward question just to make you understand how we are actually finding out the equation of polar. Okay, let us move for the next problem. It has been said, find the coordinates of the pole of the line. This means this is the equation of the polar with respect to the circle x square plus y square equals to 1. Let us say the coordinate of the pole, let us say the coordinate of the pole be x1, y1, correct? So what is the equation of the polar? The equation of the polar will be xx1 plus yy1 equals to 1, because we know that the equation of polar is always t equals to 0. Now, which is same as your ax plus by plus c equals to 0. So can we now compare, because these two lines represents the same straight line. Hence we can compare their coefficients to get x1 over a is y1 over b is minus 1 over c. So from here we are getting x1 is minus a over c and y1 is minus b over c. Right? So what is x1, y1? This is your pole. Therefore, the coordinates of the pole is minus a over c minus b over c. Right? Okay, so have you understood how to find out the polar? At the same time, in this question, I have given you to find out the pole when the polar is given. Okay, let us take another problem. If the pole of the line this with respect to this circle, what is the circle? X square plus y square minus 8x minus 6y is 0. This is the equation of the polar. This is the equation of the circle, and the equation of the polar is 3x plus 4y minus 12 equals to 0. Yes or no? Now the pole given is a comma b. The pole is a comma b. This is my polar and this is the pole. So we have to find out the values of a and b. Simple. So we will find out the equation of polar from the given equation of the circle and the pole by using the equation t equals to 0, which is ax plus by minus 4x plus a minus y plus b equals to 0, correct? So that gives us so it is a minus 4x plus b minus 3y minus 4a plus 3b, correct? Now, this equation, this is the equation of the polar. Again, they have given the equation of the polar is this. So let me just compare their coefficients to get, because they are actually representing the same straight line. So taking this to, we get so this is the first equation that we got, and let me take this to find out another equation. So this is coming to 9 over 4. Am I right? A is coming to 9 over 4. So if I put the value of A in the first equation, we are getting, so 3b is minus 16, gives us b is minus 16 over 3, right? Therefore, your A is minus 9 over 4 and b is minus 16 over 3. Is it clear to all of you? Have you understood? So that's the value of A and B, right? I hope you can now understand what is the thing. You see, every time you remember, whenever the pole is given, you have to find out the equation of the polar. Irrespective of the position, you find out that T will be equals to 0. That will be the equation of the polar straight away, right? And if the polar is given to you and you have been asked to find out the pole, you find out the equation of the polar and then simply compare their coefficients to get the values of the coordinates of the pole, right? As I have done in past two sums. Okay, so let us come for this problem. They have said that the polar of the origin, so 0, 0 is basically what? So the point 0, 0 is basically your pole. Clear? Now, what will be the equation of the polar? With respect to the pole 0, 0, and the given circle is this, the general equation of a circle. So what will be the equation of the pole? I'm sorry, what will be the equation of the polar? So if I put 0, 0, what we are going to have? Because x1 is 0 and y1 is 0. Therefore, the equation of the polar is gx plus fy plus c equals to 0, right? Now what they have said, it touches the circle x square plus y square equals to r square. What do you mean by that? That this polar becomes the tangent to the circle x square plus y square equals to r square. This polar becomes the tangent to this circle. That is, what we will do from its center. The center is 0, 0. From center, I will drop a perpendicular on the polar. And that perpendicular length will be nothing but its radius. The old conception I am using here. So what will be the perpendicular distance drawn from the origin on this polar? It will be mod of c divided by root over g square plus f square, right? And which is nothing but the radius of this circle r. So that gives us c square, I'm squaring both sides, r square into g square plus f square. Is it clear? So that is the condition that we got. Hence, our option C is correct. Option C is correct. Have you understood? Have you understood the fact? It is nothing, simply the question of pole and polar. Only the tangent part is simply included here to find out a relationship between the given constants. That's it. Okay? So I hope pole and polar conception is clear to all of you, because we have discussed this subtopic in depth. So I hope it is now clear to all of you. Okay, so let us come to the last part of our today's tutorial, is that lattice points. What do you mean by lattice points? Simple, simple. Lattice points are nothing but all points which are integers, like 4 comma minus 3, minus 4 comma minus 6. These are all called lattice points. Lattice point means it is always integer. Like if I say 4 comma 3 over 2, this is not a lattice point, because lattice point will be both the ordinate as well as the abscissa. They will be integers. But in this case, your abscissa is an integer, but ordinate is a fraction. So this is not a lattice point. Lattice point means both x and y will be integers, right? So let us take, you should know this particular term, because in the question, suppose they are asking for to find out the integral coordinates. So they will not say find out the integral coordinates. They will say find out the lattice points between this. So there you have to understand the fact. So now let us come for this. Find the number of lattice points on the circle x square plus y square equals to 25. Okay. So what they have said, in the circle x square plus y square is 25. You have to find out all the points on the circle. They have said on the circle. You have to find all the points on the circle which are lattice points. Okay? That means your x and y are both integers. Both integers. X and y are both integers. Okay, so what are the points that are possible? The possibility is when x square plus y square is 25, what are the possibilities? It can be 0 comma 5, or it can be 0 comma minus 5, right? Let me just write in this way. It will be 0 comma plus minus 5, okay? It can be also plus minus 5 comma 0, because we are talking about all the lattice points on the circle. The points can also be plus minus 3 and plus minus 4, or it can be plus minus 4 comma plus minus 3. Yes or no? So how many number of lattice points are possible in this case? Anything else is possible. Try to think. Other than these points, is there any lattice points present there? Please check it. Answer is no. So how many number of points are there? From here we are getting 2 points. From here we are getting 2 points. From here we are getting 4 points. From here also we are getting 4 points, right? So total number of lattice points present on the circle x square plus y square is 25, is basically 2 plus 2 plus 4 plus 4. That gives us 12. Is it clear? Have you understood it? So yes, it's 12. Okay, let us see our next problem. What is the question? Question is same. But in this case, the only problem is they have given you x square plus y square is less than 25. It means what? They have asked you to find out all the lattice points inside the circle. Hello? They are talking about all the lattice points inside the circle x square plus y square equals to 25. That you have to find out now. Tell me yes or no. Okay. So now let us try. We will start from when x is 0. When x is 0, your y can take 0. Your y can take plus minus 1. Your y can take plus minus 2. Because always see this one. It should not be greater than 25. Not even equal to 25. It should be always less than 25. If it is plus minus 3, then also it's okay. Plus minus 4, then also it's okay. But now I cannot go for plus minus 5. Because if x is 0 and y is plus minus 5, your y square is coming to 25. So that will be equal to 25, right? But we have been said to find out the lattice points where x square plus y square will be less than 25. So this value I cannot take. So this I have to reject. Now let us take y equals to x equals to 1. So y can be taken as 0, plus minus 1, plus minus 2, plus minus 3, plus minus 4 again. Right? Other than these values, you cannot find any lattice points where x will be your 1 and y will be some other value. No. Similarly, x can also take minus 1. So let me write here. It will be better if we write here not 1, but we write plus minus 1. If x, then your y becomes what? It can take 0, plus minus 1, plus minus 2, plus minus 3. If I take, yes, in this case also it can take plus minus 4, because in that case it will be 16 and 4, 20. Yes, it's possible. But y cannot take more than 4. Now if x is plus minus 3, what is the value of y? Y can be 0, y can be plus minus 1, plus minus 2, plus minus 3. But it will not take plus minus 4. Otherwise, the value will become 25, which is not accepted. If x takes plus minus 4, then your y can take 0, plus minus 1, plus minus 2. That's it. It cannot take plus minus 3. Otherwise, it will become 25, which is again not accepted. Now, can x take 5? No, no. No other values are possible for which we are going to have lattice points inside the circle. So how many number of points you are getting here? When x is 0 and y are taking 0, plus minus 1, plus minus 2, plus minus 3 and plus minus 4. So here you are actually getting number of lattice points. For the first case you are getting 9 lattice points, right? For the second case you are getting, so for plus 1 we are getting 9, and for minus 1 again we are getting 9. So total 18 number of lattice points possible when x is plus minus 1. Similarly, for x equals to plus minus 2, we are going to get 9 into 2, that is 18 lattice points. Now when x is plus minus 3, the total number of lattice points will be, for plus 3 it will be 7 lattice points, and for minus 3 also it is 7 lattice points. So total 14 lattice points you will get when x is plus minus 3. Am I correct or not? And when x is plus minus 4, for this one we are getting total number of lattice points as, for x equals to 4 we are getting 5 lattice points, and with x equals to minus 4 again we are getting 5 lattice points. So the total number of lattice points will be which gives us 69. Is it clear? Therefore, the total number of lattice points are 69. That is the total number of integer points, where x and y both are integers. They are called the lattice points. Such lattice points inside the circle x square plus y square equals to 25 will be nothing but 69. Is it clear? Okay, so I hope you have understood whatever we have learned in today's tutorial. If you have not understood any part of the lecture, please do comment me. I will definitely get back to you. So see you very soon with the coming videos with a new chapter. Till then, stay tuned to us, and if you are new to my channel, please do subscribe, like and share. Thank you so much.